So, welcome to the Kanban Coaching Exchange. Lots and lots of people here tonight. Great to see so many familiar faces once again. I'm very excited tonight because I've got, if I'm allowed to have favorites, but shh, don't tell the other speakers because many of them are here. But if I'm allowed to have one of my favorites, it's definitely going to be Troy Magennis. I first met Troy many, many years ago now, when I was learning about Kanban myself, and I wanted to learn a little bit more about data and statistics. And not only did I learn off Alexei Zegloff, who is here as well, but Troy Magennis was another guy that I learned some great information. And I even went on in one of his courses and learned how to do probabilistic forecasting using dice. So, definitely worthwhile checking out his website for some great blogs, literature, free stuff, and tools, which I'm sure he'll tell us about at some point tonight as well. So definitely worthwhile checking out Focused Objective. But not only is he very smart, but he's also a very fun guy as well, which hopefully he won't let us down on tonight. So without further ado, I'm going to hand over to you, Troy. Take it away.
Thank you. Thank you. So sorry about my camera. It didn't work, and it's probably in your interest not to look at me. So there you go. So forecasting. Um, I want to part of the aging process is you learn what doesn't work and you have more experience of failing. And often what I hear on sort of forecasting side, thanks for your spreadsheets, Troy, and that's all well and good. But then often see them being misused or failing in sort of larger organizations. So this talk is about a particular type of problem we have, which is multiple team forecasting where there's more than one team involved, because we often get sort of wrapped around the axle a bit when we think that we can just independently and individually come up with a forecast team by team, and then how do we combine those individual team forecasts together to understand a delivery date of something larger. So I'm going to wrap that up as multiple team forecasts. Now, I'm going to start this talk by talking about the problem of multiple team forecasts. And it depends on who you ask. If you ask leaders how they feel about the problem, they will express it one way. And if you ask the tech teams how they feel about the problem, plural, they sort of will describe it in a slightly different way, from a different aspect from it. So I'm going to sort of first of all set out the problems that we have with forecasting. I'm going to go through the history of forecasting, about how we got to where we are now and why we think what we're doing should work but doesn't. And then I'm going to sort of go into what we can do about it. So that's that's the sort of the journey I'm going to go through right now. I think as Helen sort of mentioned there, and there's two Helens. So the Helens said, I'll take questions throughout the whole talk, and won't make any Greek jokes for the Helens of Troy. All right. So the problem. Let's go. So often the technology teams feel about estimating and forecasting is that it's sort of like the complexity is just impossible. We will never understand it. Then they sort of feel that they get this sort of nerve-wracking feeling when they're asked by the leadership teams for quarterly planning or yearly planning how long something's going to take to do. They feel they're going to be held accountable for things that are unknowable by anybody, and hence they react in a very sort of negative aspect and pattern for that. Sometimes they pad them out to make sure that no matter what happens, the chance of them not delivering before the time they said is near impossible. So they'll sort of say, sometime in 2030, it'll be delivered. And that's just for changing the copyright on the bottom of the homepage. And that's a sign of that local safety, about worrying about sort of if someone else is going to depend on these estimates, then they better bloody well be right. And then they sort of also feel that leadership doesn't participate in that uncertainty. They don't understand that some things are near impossible to estimate and some things are easy to estimate. They just think that they're solely responsible for it. So these technology sort of feels because I'm told that the coachy people are all about the feels. These feels change behavior of how people approach forecasting and estimation, and make it really hard to deal with uncertainty in the workplace. All right. Anybody want to add any other sort of feels they have about sort of forecasting and estimation that they've found that cause absolute mental chaos and distress? Caesar.
Yeah, hey Troy. I definitely have a pattern that I come across very commonly, and that is that there is a management style, prevalent management style called exchanging declarations of certainty. And one of the telltale signs is when you ask some team, some individual, or a leader for an estimate, and they give you a single number. What the hell is up with that?
Yeah.
Why not
Yeah.
two numbers or a range or a confidence interval or something? But no, they just give you a number. It's
Yeah.
almost
So
it's
it's
almost
like
self-inflicted, isn't it?
it is self-inflicted. It's like sort of saying, find out what's wrong with my car, but I want an upfront quote. And like let's sort of like we wouldn't do that. We would go through some investigation of where they would open the car up and have a look at it and actually try and sort of see what's broken and then give you a quote to fix. But we expect the opposite. And I don't know that we do. I think we've sort of fallen into that habit of thinking that's exactly what we should do. So on the leadership side, and the reason why they often sort of push down and ask for stuff is that they're dealing with uncertainty beyond the technical side. They're dealing with the uncertainty of how to understand the impact of what may be delivered on the market and the customers, and they're trying to connect the dots of deployment and education and support and all sorts of things like that. And some of those are legal requirements, and some of those are just sort of if they're a publicly traded company, they're again got some requirements to be within some range of accuracy of of sales, and sometimes those sales are dependent on having a product delivered and so forth. So they're in this. They're not immune to uncertainty. They just have a different set than we do. And for them, it's not how long it's going to take us to build the stuff. It's when that's going to be started compared to all the other stuff that you've also promised sort of doing, right? So it's not when can we start this work at a leader's, well, yeah, sort of it is. Sort of it's not when the work, it's not how long the work's going to take to do that the leader worries about. They worry about when it's going to be started in the queue of other things, because that's where they have the leverage point of changing the order and priority of the things which are going to be sort of done. So from a leader's perspective, it's more about what they're really asking is when can you start this, not when can it be finished. And the two different leaders and the developer questions are very different forecasts. The developer and the team questions are, given that we tell you to start it and you can focus on it, how long is it going to take to do? But the ratio of the start time to the doing time within a sprint or within a quarter is very short. So the ratio of the time waiting to start to the time doing is larger. But from the leader's perspective, it's the other way around. The time waiting for something to be started is very long, and the time once it's started is relatively short. The ratio changes. So should the way we express our forecasts, and the same should be the way of what we help teams sort of understand and communicate. All right. So if I said we need it tomorrow, what gets dropped is really what the leaders are asking. If they ask can I get this, the right response to that is, do you want us to drop everything else to do that, or do you want it just to go into the queue? Because if we drop everything else to do it, I can tell you it's going to take about 2 weeks to do. But if it's going to just go in the general queue of in the backlog column that we're going to eventually pull because we're good Kanban people, where I I think we could probably get to it sometime in the next 6 months, and that's the point. A 1 minute dev change that would be started for 3 months takes 3 months and 1 minute. So what we really need to express to leaders is when we could start it, if it was the absolute number one priority, and a range of dates of when we could start it if it wasn't the highest priority. Because what the leadership's trying to do with this information is trade off between options that they have. Any questions, comments on this? No? Is my audio working?
It
Yep.
is.
Good.
We can hear you.
Good. So I guess you get my point. My point here is the fact that depending on who and why we're doing the forecast, it changes dramatically what we should be forecasting. One of them we should be forecasting duration, and one of them we should be forecasting when it's going to be started. And the number one problem, even in my spreadsheets or anyone's sort of method of forecasting, is often we just phone in the start date. We just sort of say, oh, let's start on the first of a quarter, or let's start on the 1st of January, or let's like the start date is given the least amount of input stress. But that is the number one forecasting lever that you have to improve on if you can. So that's what I'm sort of saying is that we asked the wrong question. Okay, and Verena there says disagrees. Good. I do not agree with the leaders need the start date. The initiatives we work on are always differently. Long teams have different throughput, hence the duration. It's then your context is different. If the duration is going to be far longer than when you actually get to start it, and think about it at a leadership level, at a product level, not just at a team level, then if that ratio changes, then you will be, if the lead time is massively different to the cycle time in your systems, then you should be more forecasting when things get started. If the lead time and the cycle time are almost equal in your systems, then you should worry about the duration. Does that so that's
Okay.
that's the context difference.
Okay.
Does that make sense, Verena?
Yeah, I mean, I still have to think about it. So keep on talking, and I keep on
Okay.
trying to remember what you just said, and then I try to make sense out of it. So thank you very much for your comment.
No problem.
A nicely shaped area of tissue damage in exactly the area.
All right. So it's interesting. So that's what I'm sort of saying here is often what I find when teams and organizations feel like they have a high degree of uncertainty, it's because they're sort of working on, they're trying to answer the question of when will it be done. But depending on the urgency of the work and depending on what granularity, whether you're working at sort of features or products or whether you're working down at the team sort of epic or story level or card level, the process should and will be different, right? And I sort of like to change the questions around a bit. When do we need to know if it will be possible? Or what don't we know about delivering X that we would need to know before we can give an estimate? What can most definitely get done by date X, and what work should we start? Or if we can't start X, then should we even continue? If you're trying to do a Christmas sort of trying to lead up to the holiday Christmas season and sell something, if it's going to be delivered after Christmas, then don't worry about continuing the website changes for the Christmas campaign because it's too late. All right. So often it's the framing of the forecasting questions that we've got to do. And you got to ask these sort of questions to the group because the reason we're forecasting and estimating is to make decisions about things and how long they're going to take to do, and if we did them and what order we do them. And if there's a lot of uncertainty in what we're estimating, then you're not going to get those questions answered in a way which is reliable or that feel like they're being successful. So the job of forecasting is to keep, just like Kanban, is to keep options open until you're necessary, until you have the last responsible moment where you're going to have to choose what you're going to pull next. But just remember that the ability to be able to change the pull order at the last responsible moment adds forecasting uncertainty for the leadership who need to know that something is going to hit the customer's machine's street at a certain date. And that's sort of the conundrum that we're in, the dilemma that we're in. We want to keep options open because that's the role of Agile and Kanban, but we're actually adding uncertainty to final delivery date because we're choosing to delay the choice of when something's going to start. All right. So one of the things I also want to add here is the fact that in doing multiple team forecasts, we get put up against another thing which is difficult to manage. And this one is the fact that when we have to coordinate work across multiple teams, then it gets we add uncertainty into the system. All right. How does that happen? Like if we have one team, there's only two possible outcomes, that they can be delayed in delivery or they can deliver on time. And so you got a 50-50 chance based on how simple the work is, how well understood it is, and so forth. But by the time you have two teams, team one could be on time, team two can be on time. So that's successful delivery of a forecast or an estimate. But team one can be delayed, or team two can be delayed, or team one and team two can be delayed. So you can see there's a 1 in 4 chance now that combining our estimates and doing perfect handoffs will cause an on-time delivery, a forecast to be seen to be accurate. And as you add sort of 3 teams there, you sort of see you get a 1 in 8 chance of on-time delivery. And this is just like flying. If you fly late in the day and the airplane that you're going to be traveling on has to travel multiple connections, any delay in any prior flight of that airplane during that day is going to delay your flight. So if you fly earlier in the day, you're less likely to be hit with a delay because your plane is probably already at the gate ready to go. The chance of the plane not being there when you need it to be has been eliminated as a risk. So as we start adding teams, the chance of our forecasts and estimates being put together are sort of equal there. And so the slides are available. I think Helen's have them already, so they can make them available. All right. So there's another one. There's another conundrum that we have, and as Kanban experts, you understand this one better than anyone, is that is there an interaction between the utilization, how busy the teams are, and the amount of time it takes them to deliver? Anyone got an option here? Is A or B right here? Put them in the chat window so we got a written record of your vote. Who thinks that utilization can impact lead time? Which one's correct, A or B? All right, we got lots of Bs, a couple of As there. And Andy, we should get married. So the chances are here is that actually both of these are correct. And that's something that often I find we teach a little bit incorrectly, is that up to a certain point, utilization doesn't really dramatically impact lead time. And then we hit a certain point and it actually massively impacts lead time. Now, the little fellow on the bicycle here versus the people in the traffic, who can forecast and estimate their cycle time, for want of a better joke word? All right, so the cyclist, even though he's going to move slower, depending on how much he had to drink the night before, these people are stuck in traffic. So it's not to do with their vehicles or team's ability anymore. It's because they're congested in all the people around them. It's very difficult for them to understand their cycle time or throughput because they're at the mercy of everyone else. And the same thing happens when we look at sort of the teams and the systems utilization. It's up to a certain point. There's enough space in the system to absorb variability. But once we get high utilization, there's very little space in the system to absorb variability. And what happens is everything gets bloody congested, right? So yeah, absolutely. We've decided that it's not working. The incentive to get people to cycle obviously isn't working in this country. One smug little guy in a yellow shirt, he should be congested as well. And the point is by the way, it's not always 80% like we often hear. It varies depending on the variability of your system. The arrival rate and the cycle time variability change when this moves exponential. And the thing about it is if we're expecting our team assets, our team estimates to be useful in and combinable with other team estimates to work out a forecast, we really require medium to low utilization in the system. And that's a unicorn. I've never seen that occur. It doesn't happen. It happens in the real world when we force it to happen, like we've done here with the cycle path, right? But mostly our systems, given that we're being asked to forecast at all, we know that there's a trade-off, that something's that they can't do everything they want to do, and by definition, the system's overutilized at that point that someone's trying to have to make a trade-off decision. And this is what it looks like in the real world. And this is throughput data for 100 teams inside an organization. And you'll sort of see a couple of interesting sort of data points on this. And there, I mark them as WTF1, WTF2 for no particular reason, right? What do you think happened? What's the cause of this decimation of almost zero throughput in this organization at any moment in time, at these two points in time? Yeah, so we like to think of Christmas. Yeah, that's good. Now, what does Christmas happen? What does Christmas cause? Yeah, this wasn't a shutdown. This company operated all through Christmas. So they had, in fact, what you're going to be surprised about here is at that point in time, I looked at the number of people who were still on the teams in the office contributing work, and there was only a 3% drop. A 3% drop in staff sent that system up into that exponential lead time period, and nothing went through. So it's a very, very small change in staff being away on vacation that can actually decimate the throughput of the system. So what does this mean? It means if you were forecasting in through December, all of a sudden everything in the system was going to take at least a month longer. So it's not just when you actually happens. Now, cut a long story short, this is the impact of a HR policy of if you don't use your annual leave by the end of the year, you lose it. So some of the most highest, some of the Elon Musk 20-year-old sort of bros who refused to take annual leave throughout the year because they were too important to take annual leave, as bros think they are, we got to use their annual leave or lose it, so they went off. And that reduction, a very small reduction in available staff, increased the utilization of the system, of the rest of the staff, to the point where nothing got through. So there's nothing you can do in forecasting or estimating that will be as impactful as a stupid HR policy. Nothing. So stop worrying about whether something is 1 point or 5 points or whether it's going to take 3 days or 5 days. What you're looking for in your forecast across multiple team systems is these seasonal events, these special cause events, these impacts that take out a very large number of staff. All right. And if you want to look at it, look it up. It's called Kingsman's formula. And the thing about Kingsman's formula, let me see if this works, is the fact that there are a couple of variables in Kingsman's formula, and one of them is the system variability, a little or a lot, and then the system utilization. And what you'll find is, if I can just zoom this out a bit here, is that you know, if you look at the cost difference there, you'll sort of see that it actually it actually becomes very large at a certain point. So the cost of queuing is $11,600. But the point I want to actually make more than anything at all is that point where the delays in the system go exponential are to do with the system variability and the system utilization. And what I find is the item and system variability is in two parts. It's the arrival time variability. If everyone turns up at the checkout counter at the same time, there's high waiting. If they distribute it over the whole day, there's no waiting. And then if people turn up at the checkout counter and they have a million items and someone has just one item, there's high system variability. Now, Kanban solves both in a very indirect way. So the reason Kanban is so effective at reducing lead time and cycle time is that by implementing a pull system, what we do is we decrease the arrival time variability. And then by dealing with blockers and delays expeditiously, we normalize cycle time. So the science behind Kanban comes down to this chart and managing those two factors in your system. The arrival time variability, do we distribute and have people start and pull work? And then do we actually make sure that work that started gets finished without any delay? So there's actually really good math behind why Kanban is a massive dollar saving, because without Kanban, and if we increase these items here, if you just look at the cost of queuing versus the cost of doing here, right? If we can reduce system variability to moderate, we actually take the queuing time cost out of the system. And we take it out some more, we reduce it some more. But if we max out both arrival time variability and cost variability, arrival time variability and cycle time variability, and we increase our system utilization, we pay a huge dollar cost for not managing these systems. And this sort of little worksheet is, I often work with this with executives because they don't understand why implementing these systems is so important, and it has to be put in a dollar terms for them. But if you can start reducing the variability of systems, you can sort of operate at a much higher utilization without paying a really high price for it. And it's going to depend on sort of your average cycle time. So I tend to say, how long is it going to be? So yeah, that's what I'm trying to get people to work on there, is to understand there's value in what you're offering them. It's not just that Kanban is a process for operating in a very faster way. It's that there is hundreds of thousands of dollars in it for you to start managing this stuff. Any questions on that? Anyway, I bring that up just because I
Yes,
think
is that worksheet available? Oh, you just linked to it. Thank you.
yeah, it's in the slides deck too, but it's all out there. Every one of those little spreadsheets are a discussion point I've had to have with someone at some point in time, because the leaders were slow to understand the impact of these systems. All right, so yeah, you got to work on spreading arrival time. You got to work on sort of managing cycle time. Both of those two things are your two biggest financial leverage factors. And why do I bring this up? Because it's impossible, no matter what forecasting system you do in a multi-team system, it is impossible. Then set it as something that everyone agrees on, Tomo, and just deal with it, because it's still going to become a massive number, no matter what you put in there. So forecasts and multi-team forecasts don't happen because of bad individual data. They happen because we haven't managed these other systems, the system factors, and there's no way anyone can forecast when they're in this congestion system like this. So we've got to deal with that first. We've got to get flow before we can actually use that flow in any forecasting or estimating process. And I think that's what I've sort of learned over the years is so anyway, there's one sort of saying, then what does it mean? How do we sort of make space for the right stuff? And where do we pay for something that we may not need? Something in the world, something in humanity and society. Where are we willing to pay for idle time? Anyone got an example?
Holiday.
Well, yeah, I'm sort of thinking we're okay with firefighters sort of cooking big breakfasts and stuff like that because we know when we have a fire, there's going to be it could be a huge cost of delay in life or property. And same thing with sort of police. We often they get so bored and lazy they go out and set speed traps because that's sort of all they've got on at the time, right? So insurance, we're willing to pay a price for something that may not even happen. All right. So we're used to this stuff. We're used to understanding that some things are so important, and a short cost of delay is hard to quantify exactly, but we can set the scene up. If this didn't ship, what could happen? And it's not that we want the firefighters to be super skilled and sort of there and that sort of stuff. What it is with why we reserve capacity is when we want to make a choice that we want to have a near immediate start time when we get a 999 call or a 911 call, depending on which part of the world you're in, right? So when we leave idle, it's so we have control over start immediacy, the time to start. And then, there are others where we don't do that. There's huge cost. The cost grows with the delay. So when do we do the opposite? When are we unwilling to pay extra for a response time and rarely accept it? We allow idle. Anyone got some examples? When is idle almost encouraged and accepted? Software development is one of them, right? I mean, I love your, yeah, I love the NHS, but I mean, they're not really incentivized for actually sort of response time. They're incentivized for triage and saving as many lives as possible, right? We're not willing to actually, surgical waiting lists, software development, right? I mean, there's a lot of these things where we're willing to sort of say, well, what are you going to do? You're going to have to wait until you get capacity, and we're unwilling to sort of deal with the stuff. And it might be simply because cost of delay is so hard to accurately estimate that we never make that understood to our leadership team so that they staff effectively to avoid those costs. Because those costs I showed you before on that little slider spreadsheet, they're accurate. I've actually seen them. And when I go into the executive team rooms, and I started doing it. Don Ryanson does it as well. He always sort of only really consults at the highest level. So he's got the board of directors or the C-level leadership team when he's doing these things. And he asked them, give me the number one project inside your company that has the highest impact if it is not delivered right now. And there's some discussion, and they eventually agree on one or two of them. So he says, now write down on a sticky note the cost per month of not having that project completed. And even inside the boardroom, there is a 50 times range. So one of the board members thinks that it's only $1 million a month, and one of them thinks it's a $50 million a month. So even at the leadership team, they're terrible at understanding the cost of delay. Now, that doesn't get better as we move down and we start narrowing in on what our field of expertise is. So down at the team level, if you're just a UI developer, how can you really understand the cost of delay of not getting that feature delivered on the market and the stock market and humanity? You can't, right? So even at the board level where they're meant to be having these big thoughts and understanding the impact that these decisions make, they get it wrong. So anything you can do to improve the understanding inside an organization of why something being delivered versus something else has a huge or different, bigger or less impact, even if it's just a pairwise comparison, which one's got a bigger impact, left or right, right? Even if it's just those pairwise decisions, anything you can do on that means that the right work is going to be started, and that stuff then can be predictably delivered and forecast. But why everyone has a misunderstanding of the cost of not doing something, it's very difficult to get any action on understanding. So, surgery takes a very short period of time compared to the amount of time you spend on the waiting list. And that's the two modalities of forecasting I want you to remember, is that it's either the waiting time, the start time swamps the doing time, or the doing time swamps the start time. And depending on the type of system you're in, you need to focus on forecasting multiple team forecasts differently. And often, and I'm going to sort of say it, I find 95 to 99% of the time in the software industry, it is the decision time to start something is 10x what it takes to do something. So if I could get one factor better in my forecasting ability for an organization, it would be forecasting how long it's going to take to when we get to start that item, that lead time. But you got to do the math. You got to do the math. Look at historical at feature levels or epic levels or something like that, some higher level, and sort of saying, how long did it take us once we started it? And how long did it take us to decide to start it? So if the lead time and the cycle time are pretty equal, then you're pretty much, you should be forecasting the cycle time. If the lead time is far larger than the cycle time, then you should be forecasting the time to start, not the time once started. That make sense? All right. Thanks, Rita. All right, so the problem, we think planning is about how long something will take, and we get guided that way because that's exactly what our tools do. Our tools show us all along how long something is going to take. They're experts at showing cycle times, and they're very poor at just sort of showing the lead time. And this is sort of my point here is the fact that we cannot know when it will be done unless we know when it's going to be started. And that sort of often is just the overlooked factor. So anyway, some history. Back when I had hair and it was a different color and I could sort of ride a push bike without falling off, and even a skateboard, we used to estimate in time how many weeks it's going to take. But then again, things would take a large amount. But when we're forecasting single pieces of work now, we tend to sort of start looking at the historical cycle times, the lead times and velocities, and we do cool Monte Carlo forecasts with very simple spreadsheets. And we sort of still can do that. But these sort of factors are about different types of things. One's work on start date, one's work on cycle time. And then we sort of moved on to, once we sort of were able to do that for a single piece of work for a team using cycle time, we moved on to the fact that can we look at batches of work for one team. And when we started sort of doing a burn down of points and sprints, or what we could pull in set WIP limits and capacity and so forth, and we started looking at similar things that have historically have been this size, this complexity of work, how long is it going to take to do? And again, we went from the old way of doing it, which was just sort of summing and dividing, into more of a quantitative sort of Monte Carlo sort of world of what I would suggest doing. So I think now we've got the tools to do batches of work for a team and single pieces of work for a team pretty much nailed, I think. If you go to focusprojective.com, you can download the spreadsheets which do both of those forecasts, and you can improve on these spreadsheets. They're just spreadsheets. There's no code in them. So go grab those, and I think you can answer those questions pretty well. The problem is when we have a single piece of work with more than one team, everything goes pear-shaped. And the typical way of doing it is to get in a big room once a quarter and try and work out how to sort of understand how the teams do handoffs and do we have dependencies catered for and so forth. But a better way of doing it is by looking at taking the system as a system and sort of saying the system historically, when we've delivered something similar to this across all of these teams, how long has it taken to do? And that reference class forecasting is already going to account for the many, many things that have happened inside your company before, which slow work down at a multi-team level. And if I could give you one tool to take away from this, it's to, when you're going to that sort of quarterly planning or you're looking at epics, write down or have some sticky notes around of last time we changed the copyright, it took 2 months. Last time we actually added a new vendor or a new credit card provider, it took 6 months. And that's a starting point for understanding that that's our system response time to types of features like this. Because if something's similar to that, you've got to sort of say, is it similar in urgency? Is it similar in effort? Is it similar in difficulty? But if it's similar in any way, then we've got something to point to sort of say our system responds in this way. And then this is where we get to batches of work with more than one team, which is reality for almost all of our sort of software development nowadays in our systems. We've got crickets. We don't have a lot we don't have a lot of solutions out there. Our tools don't really help us much, and we come up with putting red string between cards if you're the big sort of safe people and stuff like that, But we know there's a problem. We want to understand how long it's going to take to deliver a batch of work across multiple teams, but there's not a lot of tooling support out there. I mean, we try and break it down and do regular planning and swarming, so we cut down the duration, but it's hard, and I'm going to give you some solutions to that now. So one is do dependencies matter? Not all dependencies matter, right? If there are no dependencies, then the amount of time to deliver 5 pieces of work is the duration of each piece of work, right? So with no dependencies inside a system, and everything's going to take the same amount of time. So we've got a machine that's sending out screws, and we've got 10 rows of machines. We can roughly say each machine is going to put a screw out 1 per second. So we know in 100 seconds, each machine is going to do 100 screws. So now we've got 1,000 screws coming out, right? Very easy to forecast and predict, parallel when there are no dependencies between the machines. And the other end of it is that each machine does part of the process of generating a screw. So we actually have the time taken for the first machine plus the time taken for the second machine, third machine, fourth machine, fifth machine. Okay, so dependencies do matter in the case of when there's a sequential work dependency on these things, but most often this is the way our software and systems work. Some parts of the big feature and work can be delivered by multiple teams in parallel, and then there's a handoff to another set of teams which do some other work. Often the sum at the end there is the rewriting the documentation, updating the training, onboarding migrating the data and so forth. So the one you want to get good at is the sum, is understanding, take the teams which are doing the work and understanding what work can be done in parallel and what work can be done sequentially. So the thing is often what we're looking for when we've got parallel work is which one is the longest. It's not the sum of each of the teams. It's which team's going to take the longest to do that work in parallel if they start at the same time. And then then becomes the longest plus the longest in each of the parallel groups, in each of the groups which can operate independently. And, again, we've still got the case where if they're all handoffs, they go away. So your job in dealing with dependencies is to solve the dependencies that are handoffs to groups which take the longest to do their work. All right. Now, if you're in a sprint-based system, then it's sort of what you're really looking for is the team that's going to exceed along a sprint boundary. If that makes sense. But because we're Kanban, it's a bit harder to do there. But the same thing is, you're trying to get the teams which can do work in parallel to start all the work at a similar time. And what you're really trying to do is understand and sum the longest in those parallel groups. So the process is identify the build order of the parts. What needs to be done before X can start? So we've got multiple teams. Ask those teams, what do you need to be able to start this work? If they sort of say, no, you just need to tell us, okay, that's all good. That means it can be done in parallel with other teams starting their work. If they say we need X to be done, then you've got a separate group of work that can't be started until that dependency is satisfied. And then you got to work out of those groups, which is the longest piece of work in each group. You don't have to even estimate the others, other than the fact of them just saying, is it going to take you more than a week, 2 weeks, 3 weeks? If they sort of say, no, it's within a week, then that's a good enough estimate for that work. And then you want to sum together the longest. And you might want to bump them up a bit just to give yourself some safety. But I have a tool which does this automatically. And no one's using it other than me. But the point is it's a different look at forecasting, because what we're really looking at is the dependencies that this team is blocked until another team finishes their work. And it understands the rest are roughly within parallel groups. So the ability to quickly define the groups, a demo here for a second. All right. So what's happening here is it's giving you the forecast. The likely forecast there is 33 days. Why is that different than the perfect forecast? Now, the perfect forecast is the sum of each of the items that can be done in parallel. Well, it's because this feature here cannot be done until the screenshots are done on the website. And the estimate for this isn't an estimate on any sort of size. It's an estimate of prior work that the team has done. So there's no point estimates in this spreadsheet at all. Now, what that means is then until the screenshots get done, which is this one can't be started. So once that's done, now we've got the ability to pull the work. So what I want to see us be able to do on our Kanban boards is being able to show, gone out of the way there for a second, when things are blocked because other things need to be finished. Because what we need to do is we need to make sure that we chase up and we discuss this one because it's blocking the ability for something else to even be started. So the way to get the forecasts shorter is to rigorously deal with the things which are blocking other work from being started. Now, Kanban often makes an art form of dealing with blockers of things once they're started. But if you could deal with the blockers of things that are unable to start, you will make your forecasts so much more accurate and your system flows so much smoother. Because what you're really allowing it to happen is you're allowing other teams to start the work they need to start in order to get it done. Yeah, I think go out and use it. It's free at the heycasey.io, sign up and have a look at it. It's still doing a Monte Carlo forecast. It just sort of makes it a bit easier to understand, and it doesn't require full-on estimates in there. It just uses that historical data. And this is based on, I think, 12 pieces of data. There's very little data in order to get this sort of likely forecast there. But without it, your Monte Carlo would have given you 12.4 days. But realistically, knowing the system and the delays in the system, because of based on forecasting the start durations, not the throughput, we're able to much more accurately understand the likely forecast. So anyway, I'm trying to guilt all the JIRAs and stuff like that into doing forecasts in this way. And I think until we do something like that and we start dealing with start cycle time, the before start, the time in the ready, the time in the backlog, but it's not able to start process, all forecasts on multi-teams are going to be crap. Anyway, there you go. I said it. Yeah. I mean, there are other things in there. Just, I mean, just to make it look good. This is just sort of showing off now. But the idea here is to be able to sort of see what work is being involved and what teams are doing it, and if they've got time to do that. Because if I set this back a day, you'll sort of see that all these teams are way over capacity and there's no way they can deliver anything. So keeping the utilization under control is what the job of this sort of sheet is, and seeing what has to be done in order to deliver a feature holistically is what's needed. And then when they're blocked, showing them as blocked, and so forth. And that's sort of where we deal with this sort of stuff. Yeah. Any questions at all? But you can sort of see what I'm saying is I don't think the current tools do a very good job of solving the overutilization problem that makes it impossible to forecast. And they certainly don't show the it's hard to get started problem. Anyway, wrong order meter. Can teams predict the start date? It's hard because of changing priorities and whether a team should react faster and what they should react faster to. Does process matter? I think it does, right? I think that the whole concept of this stuff is about the longer the sprints, the more delay you get where it misses one sprint and can't sort of move across to another. So Kanban has a massive impact there because when it's done, the next time another team has a decision about what to pull, they can pull it instantly. They've not got that dead time between the end of sprints and the pulling of something urgent. And think of production outages. When there's a production outage, we're very good at eliminating the process around when people start it. We tend to have them waiting there ready to start it. Right, can you test it? Can you put it out in production? Can you put it out in the staging environment? And everyone, and so Thomas says, Microsoft Project did this. There's a reason why they did it. Yeah, all right. All right, so managing blockers is sort of an important one. Going a bit over time now, so I'm going to sort of what changes the order of when we should start things. You need to ask that question in your organization. So whenever something didn't get started, the question you got to ask is, what caused that not to be started? And if that's a valid reason, embrace it. But if it's an invalid reason, understand, well, we just didn't start it because someone didn't reply to their email. That's a bad reason. And that's a system reason that makes your forecasts impossible to hit, right? Because now there's no column in any Jira tool which sort of says the response time from the knowledge expert in this area. It doesn't exist, right? When we forecast, we're trying to guess what it's going to take to do the little bits of work. Can we get teams to know what to start next is the key skill. If you're actually trying to coach teams, it's getting them to understand why they start things in the order they start things, and can that be improved? And if it can't be improved, what caused it to be wrong? And if you go back to focusobjective.com, this is why I had this wrong order meter, because what it's trying to get people to do is understand that we had an order we wanted to do things, and this is the order that we actually delivered them. Let's discuss the internal politics that caused that to occur, and then we sort of move along that aspect of it. Okay, so I find until I can get organizations to score highly on the wrong order meter, in other words, deliver in the order they planned, multi-team forecasting is a farce, because they're going to do other things anyway. What exactly are you forecasting in advance? Nothing. You're forecasting a fallacy and a fiction. So get companies to understand why they pull in the order they pull, and remove the BS reasons that are causing that to be wrong. All right. Can we get teams to know what to start next? That is the key. If you can get all the teams in the organizations to better understand what they're going to start next and why, universally, everything becomes so much easier.